Hello, this is Ms. DB. In this video, we are going to look at how to do some of the problems on the Chapter 12, Section 2 worksheet. This is on translations of figures. So a translation is a transformation where all the points of a figure are moved the same distance in the same direction. This is an isometry. We talked about isometries in the last lesson. The image will be congruent to the pre-image. Remember, the pre-image is the original, the image is the new. They will be the same size, the same shape. So for the first section, you just have to answer yes or no whether or not the figure appears to be a translation. If it's yes, you can just write yes. If it's no, say what's wrong with it, that it's not a translation. So if it is a different size, it's not a translation. If it's been reflected, it's not a translation. If it has been stretched or shrunk or rotated, it's not a translation. So they need to be the same size, the same shape, but has moved left, right, up, or down, or a combination of those. Then in the next section, this is how we would translate something on paper with a vector. So we've talked about vectors before. They tell us direction that something needs to move and also distance. If we have a translation vector, then you would take the pre-image, which in this case is this triangle, and you would apply this translation to every vertex, draw the new vertices of the image, and then you could connect them. So you would basically copy and paste this vector, this translation vector, onto each vertex of the pre-image, retrace that line, and then you would get your image. We're not going to do that because it's way too hard to do on a Word document. So we're going to do our translations by using these rules in the coordinate plane. So the vector, remember a vector can be written with the horizontal change as A and the vertical change as B. That's how we're going to be writing our vectors. They have these kind of sharp parentheses around them. You can use the less than and greater than sign if you need to write those vectors. So here's how it works. If you are going to do a horizontal translation, so along the vector A0, so just straight right or straight left, then the x-coordinate, you will add the horizontal component to your x-coordinate. The y-coordinate will stay the same as it was in the pre-image. If you do a vertical translation along the vector, so it'd be 0, and then the y-coordinate has a value, or the vertical component of the vector, then you would add that number to the y-coordinate, and the x-coordinate would stay the same. A lot of the times, it'll just be a general translation along both of these. The horizontal and vertical components will have numbers, and then you will add the horizontal component A to the x-coordinate, and you will add the vertical component B to the y-coordinate. Now, of course, these could be negatives. A and B could be negative numbers, and then you'll actually be subtracting from the pre-image vertex coordinates. So it's easier actually doing the problem than just explaining how to do it. So here we have triangle JKL with vertices J at 0, 1, K at 4, 2, and L is at 3, negative 1. So that's this one right here. And we are going to translate that along the vector negative 4, 2. That means every x-coordinate has a horizontal change of negative 4. So we're going to subtract 4 from every one of the x-coordinates, from 0, from 4, and from 3. And then the y-coordinate will change with this vertical component. So we will, oops, here's the vertical component right here. So we will add 2 to each of the y-coordinates. So the rule is to take x minus 4, y plus 2. And we do that to every coordinate, and then we get our coordinates of our image. And then you would graph those coordinates on the using Sketchpad or by hand if you're doing this by hand, and then connect them to make a triangle. Now you may have learned about translations before and used the phrases up 4, down 4, you know, left, right 2, or left or right 2. And you could apply that to the translation too. This translation with this vector would mean to go left 4 and up 2. And you can see that that is what's happening. It's going left 4, up 2. But we're going to use the vector terminology to practice that and to learn about doing translations using a vector. So for 7 and 8, again, you could print this and do them by hand, or make it on your own coordinate system if you have graph paper. On these two, the pre-image is already graphed for you, so that cuts down on your work. So you will find the coordinates of D, E, and F by using this vector. And when you have done that, then you will graph the new coordinates and connect them to make a triangle. So let's see. So I'm just going to use the space over here to write what the new coordinates would be. So for D prime, I have to take the original x coordinate of 2 and I have to subtract 2 from that. So that would give me 0 for the x coordinate. For the y coordinate, it was 4 and I have to subtract 2 from that as well. So 4 minus 2 would be 2. So D prime would be at 0, 2. And you mark that with the little apostrophe after it means D prime. And then you would repeat this step for E and F, and then you'll get your new triangle and you'll sketch it in there. Now when you're done, triangle DEF should be the same shape and size as your pre-image. So D prime, E prime, F prime, and DEF will be the same shape and size, but the image will be translated, will have been moved from your original. And then in 9 and 10, you do the same thing with the additional step of the pre-image is not on here yet. So you'll need to graph the pre-image. And I want you to write the coordinates of the new image after figuring out what those coordinates would be. Usually it is best to figure these out first and then graph it. There's 2 more questions on the worksheet after you draw the translations. There's some application problems. And in the first one, we have Lee and Derek are tossing a flying disc, you know, like a frisbee. Lee stands at the coordinate 2, 5 and throws the disc to Derek at 11, 0, and you have to find the translation vector from Lee to Derek. So what was the translation? How did you go from 2 to 0? What's the horizontal component? And then what's the vertical component? So to get from 2 to 11, you would add 9. To get from 5 to 0, you would subtract something, so that'll be a negative, and then you put these brackets around it. The less than and greater than sign work pretty well for that. They're a little sharp, but that's okay. And then the next question is interesting. We have a builder trying to level out some ground with a front end loader. He picks up some excess dirt. He drew a grid over where he's working at 9:16, and then he goes through along the vectors, these 3 vectors, to get to the spot to unload the dirt. So first he goes horizontally -6 and vertically 0, then horizontally 2 and vertically 5, and so on. And you're supposed to find where he'll end up. So that's an interesting problem, and it might help you to look at Sketchpad and actually translate this point along these vectors and see where you end up. All right, that's it for today. Thank you very much, and let me know if you have any questions.